is chapter 2 of what were we doing? The Well-Grounded Data Analyst. Check the description for the what am I looking for? The sorry, my brain's a little foggy today. There's links in the description for the live book as well as the yeah. I hope the description came out right there for that. So I'm going to complete chapter 2 and finish up with the project that started yesterday with encoding geographies. Then I'm going to move on to practical statistics for data scientists and the data and sampling distributions, binomial distribution, chi-square distribution in chapter 2. And yeah, and then so we'll get started on that data modeling project, and hopefully you can complete it. I do have a little bit of a buffer day tomorrow, so this might bleed over into that day. So chapter 3 data modeling might end up being completed tomorrow, in day 18. Okay, so there we go. Okay, what else do I want to do here? Besides just get started. Yesterday, what did we do? It's good to do a little recap. Was just trying to get back into the swing of things. I don't need this features share thing on there. So, added the comments and so what did we do? We did yesterday, no meetings. Notes, long tail distribution, students T distribution. So we created a note for long tail distribution with definitions for the tail and the skew, long narrow portion of a frequency distribution where relatively extreme values occur at low frequencies, the tail. And one tail of a distribution is longer than the other, then that's skew, right? And left skew, meaning that the tail is on the right. It's when the meat of the data is skewed to the left, right? And then so right skew would be the opposite, right? And let's see, so we did the T distribution. That's the parameter that allows the T distribution to adjust. Oh, that's degrees of freedom. Adjust to different sample sizes, statistics, and numbers of groups. And we actually have a 90 in our 90% confidence interval estimation. We have this X bar plus or minus this T statistic with n minus 1 degrees of freedom of a 0.05 half there, right? So yeah, so that's just half of the alpha value or something like that, where the alpha is the amount that's in the tails, the probability of something happening in the tails. And then the standard deviation being S, and then divided by square root of n. Let's see. Fleshed out a little bit more of my data analyst note as well, and added the tools and technology skills, fundamental skills, meta skills, and tools from the book by David Asboth. And yeah, I think that is a pretty good list, and I want to make sure that I'm fulfilling those things, right? So the responsibilities we grabbed from like one of the, I forget where we grabbed that from, but let's see. Oh, this was from Alex Freberg's data analyst builder website. Which I need to go back to at some point soon. I didn't schedule that. I should have scheduled that. But we were working on the Well-Grounded Data Analyst. And we have a results-driven approach to data analysis, a note that we created from that book, right? And yeah, and then I fleshed out a little bit more, added a little bit more to the process that David is talking about with iterate if necessary. And I'm thinking that the output of that step should just be a decision whether to refine your answer or quit. Is it worth pursuing further? And so we did a little bit of that process yesterday with, I tried, I'm a little rusty, and had a little bit of difficulty getting that first iteration. I always get stuck in the details when I should just really try to take a more higher level view. So at least with first iteration, right? It's kind of like, but this is the training, right? This is part of the training, is to do projects, learn on the job, right? Learn by doing these projects. So any advice that you may have if you're a professional and you're watching this and you have some advice for me, feel free to drop it. I welcome any kind of constructive feedback. Point out anything that maybe you think like, oh, you noticed that I couldn't really handle a certain thing when you would expect a junior analyst to be able to do that. Point that out to me, and then I can focus on fixing, on filling in that gap. And yeah, so I greatly appreciate any feedback in as far as that. And if you're if you're someone aspiring to become a data analyst, and yeah, feel free to ask questions, ask yeah, comment anything you'd like to comment, and just chat. We can have a conversation. Let's see. I'm gonna get some music going. I forgot to get that started. I need to make a checklist of things I need to do before I get started. Oh, and I also did not start the. Yeah. Okay, we'll get the music going. Also didn't start. Didn't start something, and I need to find out what that was. Right, the ticker. So I just need to do a little bit of housekeeping here for a little bit. And oh boy, okay. I think it would be photos and chat, and then if we move away. My overlay. I should probably just add an overlay thing. So yeah, if not, the scene is. Just bear with me for a moment. Stream marker too. Yep. What I want to do is a hotkey, right? Hotkey source. We want to show that, and there we go. Okay, but I also do need to change the ticker. Yeah, this kind of sucks. Should kind of save the output of that. I need to work on something better for that. Try to do. on that in a second. Let me... One other thing started. Okay. So did they... So really just continuing getting inspiration. Okay, so what I also just need to do is to do a little bit of yeah, okay, so video description is going to be that there. I want to move this up because this is, oh gosh, what's going on here? Yeah, because what I want to do is I need to have like a stream checklist of things to do while okay. Add live chat comments. Yeah, so we need to do that there. I think that works. It's gonna be stream starting checklist. Need to do some stuff here before I really get started. In case I like ever miss a week again, I can come back and quickly get back into this. Yeah, such a live chat over the top chat. Should be live chat, right? Let me see if it's still on that. Yeah, it is. Okay. Okay, now what do I want to do? gotcha. So I do that, and then I need to update the right? Do is maybe I think I can cut it. I think that's it. No, that's not what I think. That's it. Yeah, that's it. Okay, that's good. Yeah, and that opens it up directly. Beautiful. Okay. Yeah, that should speed up some of the work that I have to do in the morning to set this up. Let's see, what else can I do? Ooh, add the live chat comment to there, and then what else do I do to refer to do administration stuff? Let's see. Yeah, I think that's mainly the things I need to do. The ticker, other thing. Huh. Okay. Yeah. Okay. I think I'm set there. If I need to modify that, then I'll modify that later. It's okay. All right. So let's get our brain around this here. Also want to open up the Well-Grounded Data Analyst in another page here, and we'll just mark down. No need to have it open twice. I need to actually, maybe there's a setting that I can change on annotator. It shouldn't automatically open up as that. Yeah, I don't want that. I don't want it to be using that as default. Yeah, that's fine. So default is pagination. That's fine. All right, because yeah, I want to go through the summary. So do the summary. Still haven't figured out how to cite this book. That's fun. Okay. Now I'll just get the code up and running here. Let's see. Oh, Carl. Go over to notes and what things do I have there? Oh, project ideas. Yeah. I don't know why I have that. Let me take a look at that for a second. My brain's just going crazy here. What's for dinner? Oh yeah, these were some things. Let me take the notes. Yeah, I'm kind of curious about that. What I want to do. What is that? Oh, recipes. Okay. I'm gonna just do archive. Put that into there. It's just messing stuff up. Okay. Okay. Get our IDE up and running here. We were on iteration 2. I don't know if I like the pop-up. I think I'm gonna disable that for now. And maybe I'll just zoom in if I want to highlight something. Okay. Yeah, I think I'm just gonna disable that there, and then if need be, I think I have my my zooming thing set up here. Is that not working? Really? Wait a minute. Something's not right here. There it goes. I don't know what is going on there. Okay, so I do have my zoom. Oh, but it doesn't really do what I want it to do. Okay. Yeah, I guess it's only really gonna work if I'm over here. Weird. That is so weird. Totes weird. But if I'm over here, okay, something's totally screwy here. It works over here, but not in the other thing. Not over here. What is going on? We're on the right. Wait, let me know chat. Oh, I think I know what's going on. You know what I'm gonna do? That's what's gonna happen. Bear with me. I gotta copy the transform is what I have to do. That's better, right? If I'm over there, then if I'm over in the middle. I can zoom in on the side there. That's okay. I guess that's, I don't know. I don't love it. It's gonna be a workaround though. I don't love the transitions aren't working. Oh, I think I know why. Okay. Yeah. It's fine. It's just these ones. Okay. Okay. Cool. Okay, so I can zoom in over here and do that. I don't like that. What is going on there? Ah, boy. Okay. So it can't be a scene. It has to be a source. Well, that sucks. I don't know how to work this then. I need to get some lower thirds up on here too. I should install Python too. Actually, I can. And where it is. Okay. I don't know if that's gonna work. Yeah, I need to change something. It's not quite working the way I wanted it to. From the left, it's going to be slide right. don't know why the transitions got all fucked up here. Okay, I think that works. Oh no, I know what it is. It's the move transition. Never mind. Oh gosh. Oh. Yeah, that's what's missing. I'm missing the move transition. That's weird. What happened to it? That's so odd. Oh my gosh. What is going on? Huh? That's so weird. Oh my gosh. Okay. Something's so screwy. Something got so screwed up. I don't really want to futz with this right now. That sucks. Why did I lose? How did I lose that? There's no new update. It's so weird. Right, OBS got really screwy here. Just testing some things out here. What? I don't know what's happening. Why am I... My automations are really screwy. Well, that works, but then it goes right back to that. I'm so confused. This is so weird. Confused as hell here. Should be going 15. Well, I guess it's, I really don't like this. I'm gonna take a break and I'm gonna fix this. Actually, no, I'm not gonna take a break, but I am gonna fix this. So, bear with me for a moment. We need to set up a couple move transitions. So this is going to be move left. This is going to be from the right. And then I need one to move right. First thing, match nested scenes, cache transitions. Using exponential in. For the appearing items, right. The position's going to come from the center left, I think. Oh, just from the left, I think. Okay. Why does left not do, or right not do the right thing? So weird. Assume. So what I'll do is I'll just delete this one. Oh, really? Okay. Yeah, just do the same thing. These in and out range exponential. Right. And not soon. To the left. So it's going to be circular, I think. I'm moving. Wait a minute. Yeah. Wait, what? Appearing items. Okay. Should be the other way. For moving right. Oh, I know what's going on. Okay. Here we go. So if I'm moving to the right, what's appearing comes from the right. Things appearing come from the right. Things disappearing go to the left, right? What? Disappearing items. Yeah, I think that's right. Okay. Moving left, they appear in the left. Yeah, I think that's right. Okay. My goodness. What a time suck this is. Okay. Focusing on the left display, we're gonna move left. Focusing on the center is going to be a swipe down, I think, and then focus center from the right. Oh, wait. I gotta do this backwards. There we go. Okay, I think that works now. My goodness, what a pain in the butt. Pain in the balls. Back up my settings. I don't know how you back up the other thing though. I think this works now. There we go. I mean, I don't like the... I actually kind of like that. I think it's pretty cool. All right. Well, I'm going to take a quick break. And then we'll get started on creating a city column in here and see if this works. So it doesn't quite work the way I want it to, but that's okay. I'm going to create a city column. Do this. Okay. Really wish I could zoom to... Yeah, I don't know. Oh, boy. Okay. Yeah. Be back in like 10 minutes. City column. So where I left off yesterday in the identifying customer geographies here. Oh, let's set the stream markers. No, that'll start in there. Okay. I'll just run all these again and then pick back up. So we're under creating a city column. We did yeah. This first one is really mainly just trying to work with this data here, this address data, trying to clean it up. We worked through the cities data frame that was grabbed from the UK government website there. Let's see. So we need to create a column. Yeah. So we can use our city list to tag an address. We want to, the goal here is creating a city column within the addresses data frame or within the customer's data frame. And yeah, and then being able to work with it from there. So it looks like we're going Yeah. I think we can do that with a lambda apply here, though, as well. We can use our city list to tag an address with a particular city. That city name and an additional comma are found somewhere in the address. So using figure 2.11 is an example. Assume that an address that contains the substring Bath is an address in the city of Bath, so the value in the city column will be Bath. Anything there... Anything where this newly created city column doesn't have a value, where none of the city names was found in the address, will be categorized as other. Right. And his suggestion here is to iterate over these. This seems like a bad pattern, but I don't know what the alternative is. I mean, we do have a very small data set, so we can do this. Address clean. Right, we did add that. Okay, so that is a column, right? Contains oh, right, this is our condition. That's why it's not syntax highlighting isn't working. So we're locating all rows where the customer's address clean string. Yeah. All rows where the address clean string contains the city with the next line, but that's not always true, is it? It's not true for everything. In the city, I don't know if that's true for everything. And then we're gonna fill the NAs with other. See if that works. Oh. Right, so we're adding a column. And we're doing this kind of weird assign here using the label locator. Okay. All right. The problem with this approach, though, oh wait, no, because we did drop those, right? We dropped the ones that didn't have. Because there were very few, right? Yeah. Hmm. Right. Oh, yeah. So I want to see the value counts to make sure that we have the right amount, right? Because we probably made a mistake somewhere, because I don't think that this is going to be accurate. I think we're going to have too many others. Yeah, there's way too many others. We need to figure that out. That's way too many, too much data missing, right? And so to communicate, yeah, but I mean, I'm not sure if I agree here. How did we handle the? Uh, Wait. I might be missing something. I don't know how we handled the new line. Well, everything has new lines in it. Okay. I guess, yeah, because there were only 6 that didn't have the new line. Interesting. Okay. I have to like try to suppress the urge for me to like data engineer this and be like, we want to make sure that we're getting everything here, that every single value is coming through, right? So we need to handle every single edge case. But I have to remind myself that we're doing analytics here, and we're trying to answer a question, and there are some things that we can just ignore, I guess. So let's sample other. So that we get the right thing here. God. I'm tired. Basildon, Pinner, Earls Cross, Buckinghamshire, Middlesbrough, Cleveland, Twickenham. Okay, so some of the addresses relate to towns, but there's an address in Twickenham, which is a suburban district in London. That's what I was talking about yesterday. While the address did not contain the word London, the customer should be categorized as being London-based. We can already see some of the shortfalls of our chosen approach. At this point, we note them down and may consider tackling them in a future iteration. So, unless you have knowledge of UK geography, you may miss these instances of London addresses without the word London in them. This highlights how important domain knowledge is for an analyst and why you should work closely with domain experts. So one sanity check at this point is to see how many unique cities are in the government data and tagged address data. Depending on the business, we might assume that we have at least one customer in every major UK city, and we can verify this. A Python trick is to create a unique set of the government city list and the list of unique cities in our new city column and subtract one set from the other. This will give us the difference between the lists. Nice. That's a nice approach. I like that. I guess convert the cast the cities series. This and make it a set, which is pretty cool that you can do that now. I guess because these are iterables, is that why? Kingston upon Hull is the difference. So we have one that's missing. Southern means we have no customers there, which is not impossible given its population is only, how do you know that? 250,000, or there is something else going on. The city is usually abbreviated to just Hull, which again is a case of applying specific domain knowledge to the problem. Let's look for that in our address data. Right. And customize. Oops. Oopsie. So if it contains that, let's take a look at that. Okay, we do have quite a few that say Hull. Kingston upon Hull. Now, what if it were abbreviated Kingston? I wonder if we have that as well. We do have Kingston in there as well. Lewis. That's weird. Okay. Now what we're going to do... Oops. We're going to set all of them there. Okay, so reviewing the analysis so far, the work done and alternative steps shown in figure 216. So we investigated missing data, dropped missing addresses, tried to extract city column from the address, looked up cities from external list, create city column, explore new city column. Alternative options at this step could be to fix additional problems, which is Twickenham should be London. We fixed the whole data problem. And we could also enhance city information with external town list for more coverage. We can now finally take a look at spending figures by city using the newly created city column. Did I okay. Okay. Analyzing spending. Which one was this? It was 2, 3. I think it was 3. I think it was 3. So analyzing. Spending by city. And we're going to have Matplotlib. I think I have this installed already, I'm pretty sure. It should be because I have used it before in other projects. Func formatter, that's interesting. Wonder what that's used for. X piece of shit there, and return. Oh no, how do I get that? How do I get that symbol? Now I'm curious. You just copy paste, but I don't know. I want to find the ASCII or the British pound. Oh, 0163? Is that it? There it is. Okay. Interesting choice of formatting here. I usually do F strings. I'm not sure. Gonna show figures in the millions. Okay. Creating a formatter. Creating a formatter. Creating the subplots. Okay, customers grouped by city. horizontal bar plot. I think. Oh, we didn't quite finish. Setting the x-axis major formatter. Interesting. Okay, so I'm kind of learning something from some formatting. X label. B total spend. This is a neat little graph there. Most is from other. But London is the largest city here, where the customers spend money there, where the customers are based. It's clear that the other category dominates. As we have seen before, our customers are just as likely to be based outside of a major city, partly down to how cities are defined in the United Kingdom. There are only 76 that are officially called cities. There are many towns with significant populations. The distinction between towns and cities partly explains why the other category is so large. So another observation is that London does indeed come out as the top city in terms of customer spending, as well as the number of customers. The next largest cities in the terms of spending, Manchester and Birmingham, are also the next largest by population. The top cities in both this chart and our customer volume calculation in figure 2.14, Leeds is perhaps lower than you would expect based on its population, but there's no reason customer spending figures should correlate perfectly with population. Our final inquiry is to compare London against the rest of the United Kingdom. You can take this to mean either all of the United Kingdom that isn't London or all major cities except London. We should calculate both figures and decide how to report our findings, right? Oh, gosh. Should go back to, what was the question again that we were answering? Which UK cities are currently underserved, right? And whether the customers approve it. They're yeah, that based, okay. So Preston and Belfast seem to be on the lower end there, right? So but we do have so what are the ones that are below that? Because there are quite a few. I think we had 76 total in the data set, and we yeah, we represented them, all of them, right? So we have all of them. And then we had 76. So we have 20. We're taking the top 20, and then so yeah, we have over 50, 56 of them, and that would be a good list to look at. Okay, you have a whole bunch that are not getting, hardly anything from. So, I mean, maybe that's a function of like a lot of the stuff being in the other, but who knows? Maybe those other cities are more sprawl-like, with lots of suburbs and such. All right, so finding London. All right, so let's go ahead and print this here. I don't know why he's doing. Okay, so he does want this on a separate line. We're going to print the total spend, summing up by right, total spend for all customers. We can get the total spend funding customers. For London, on the total spend column, and we're going to sum up that as well. And then we're going to print out the total spend for total spend outside London. Kind of want to call an audible for tomorrow and dive into pandas methods and stuff rather than going into linear regression. Just because I'm noticing that like it's a little harder for me to understand a lot of the pandas code now, like the location. Like I understand what it's doing, but I'm not sure. Like I'm not confident I can create it. The false. Oh, that's just rough telling me that that's bad pattern. We can also do this and negate it. All right, I mean, this isn't the greatest. We have 490 mil. We have 103 mil for London, and then 387 mil outside. And then outside of London, including other, is 119. So London is pretty big. It's almost half of the major cities, right? It's almost as much as all the other cities combined. It's kind of like gotta be a power law type of thing going on here. Oh my gosh. Analyze and visualize spend by city. Alternative decision. Oh, that's why. All right, so alternative options at this point, where we have our minimum viable answer, right? At that point, so we can put that underneath there, I think. That'll work. Okay. At the end of this process, we have our minimum viable answer. We're ready to bring it to our stakeholders, so we review future steps. So after cleaning the data and extracting city information, we've arrived at an answer to our analytical questions. Our customers spend the most in bigger cities since they are generally more customers. There are generally more customers in larger cities, and London generates nearly as much income as all other cities combined. This insight, coupled with the table, the chart, would fit on 1 or 2 slides to present to stakeholders. Okay. So after presenting the results, our stakeholders may want us to continue the analysis and get a more comprehensive answer. What could we do to improve the solution? Perhaps, as discussed, we could identify the city or town an address refers to by identifying the postcode. For that, we need a comprehensive list of UK postcodes, the assumption that all values in the customer address field contain postcodes, and the assumption that we can find the postcode every time. Another option is to expand the current city list to include towns above a certain population. However, this wouldn't solve the problem where sometimes the name of the city or town is not in the address. Another option is to send these addresses to a third-party geocoding system, such as the Google Maps API, which would find the best match for an address we provide, and resulting data would contain a field for the town city that we could use. However, this particular option raises privacy concerns. Do we want to send all of our customer addresses to a third party? Are we even allowed to do that? This might be actually a case where a large language model could help in parsing that data, right? In parsing the addresses, and then using an agent to connect with an API to like open street data or something like that. Could use Google Maps as well, but to keep in the idea of using open source, free and open source, and love FOSS software. That's redundant, but yeah. So there are options there. But you'd have to run like free and open source large language models. I haven't really looked at. I'd like to do that. They're going to be, I mean, still going to be, it's going to, well, some of the more basic ones, like the smaller models, you can run on machine that you have that just happens, just get a pretty beefy machine and run it at home. That's one way. This can help you understand whether there are cities where customers are spending less than expected based on their city's population, therefore being underserved. This was one of the stakeholders' initial concerns. This would be one way to address it further. Can start to see how many additional considerations are involved in solving a real business problem. This is why it's vital to arrive at a viable solution as soon as possible. These additional possibilities are only considered if there is tangible business value in doing so. The value of any further work should be decided and collaborate with these stakeholders. Okay. Well, further project ideas with the data in each project chapter encourage thinking about possible research questions to answer with the data unrelated to the specific chapter project. It's an exercise that help make your solution really your own and let it stand out in a portfolio. Here are some ideas to get started. What do customer spending figures look like at different levels of granularity? You would need to either dig down into sub-city levels, such as boroughs, or figure out how to group addresses that belong to the same geographic region. Can you identify business addresses and consider comparing customers with private addresses versus those with business addresses, and augment your geographic analysis with population figures or other demographics? Are there any patterns, such as a relationship between the wealth of an area and the amount of customer spend? Could also calculate spending per capita for each city. See if that varies across the country. I like that idea, spending per capita. We'd need to get population data, right? That would definitely help to see which ones are underserved, because if you have a very low spending per capita, then there's customers there, right? And like if you have a low spending per capita in a large city, there's a great spot, right? That looks like an area that you're not serving well, right? That's how I would take it, I guess. All right, so to use the rest of the book, and I kind of have my own idea about how I want to use the rest of the book, because I am keeping in mind that I'm using this as inspiration for other projects that I can do. Outside of this, but using the same framework. I really like the framework that David is putting forth here. it's helpful to have a roadmap of sorts, right? Like a scaffold to work through when presenting your work, right? So that like you have a structure to it, not just with working through it and like you work through the steps, but also in presenting the answers, right? Presenting your results. So this is what David suggests to reuse the rest of the book. So this chapter introduced both specific example of the results-driven approach in practice and format of all the projects. I'm gonna need to take a nap. I'm like really kind of foggy here. Each project throughout your career will require you to ensure you understand the problem. Think about the end goal you are working toward. Consider whether you have the right data. Identify the caveats you would need to flag when presenting your findings. Document what further work is possible once you have arrived at a minimum viable answer. Each of this book's projects addresses a different topic you will encounter in real-world analytical projects, and they will all follow the same flow as the one in this chapter. Okay. So the summary is using a results-driven approach helps focus on the specific problem you're solving. Part of the results-driven approach is to ensure you understand the problem before starting the analysis. Let's go ahead and be a monkey here for a second and copy this over. Using a results. Okay. Yeah. Envisioning the end result at the start creates a goal to work toward. It's always helpful to have a idea about what the answer should look like, right? That's just a general problem solving like framework, I guess. Like just the notion of a problem solving is that when you dive into a problem, you should have an idea about what your solution should look like at the end before you like start making a plan to solve it, basically. I mean, that goes back to and, that applies to mathematics, to a lot of things. Hi, Navjot. Yeah, so it is this book here is not about not specifically, well, it's not general Python, specifically about data analysis. So this is called the Well-Grounded Data Analyst. So check the description and you'll find links to the live book on Manning.com, and you can feel free to follow along here. But basically, I'm just working through the projects that are presented in the book. Analyses will differ depending on the choices and assumptions we make. So seemingly smaller tasks such as extracting city information. That's a tough problem. So it benefits from a result. Okay. I bet if I looked at George Polyev, I think that's his name, Polya, the author of How to Solve It. Yeah. So there's a book about solving general like mathematics problems, written by Polya, and I think if I took the approach that he does in that book and compared it to this one, you'd probably be able to abstract between the two, figure out that it's basically a similar process. All right, I'm going to take a break, and when I come back, I'm going to switch focus a little bit to go into the practical statistics for data scientists and look at a couple distributions that I need to refresh on. And let me open it up again. Oh no, you know what? What do I want to do here? Yeah, I'll just open it up over here again. Yeah, and we'll do this. We'll just beat that. Just get this set up. We're still on chapter 2 with that one. There was no code for the student's t-distribution, but I would hope that there's some examples here for binomial and then the chi-squared. So that's what we're going to dig into when I come back. I should be back in about, I want to set a timer for 20 minutes, I think. Yes, he says this book seems nice. Checking out the index, and every chapter has a project associated to it, which is a nice approach to learning. Yeah, I agree. That's why I kind of like jumped back into doing projects now. Is try to find like where the gaps are in my knowledge and like where I need to improve. Because those will come about when you start trying to solve something and then you just don't know how to do it. So that happened to me yesterday with trying to handle the address string. So it's like, man, what approach should I take here? Because I kind of want to do it quickly, but like if that's a kind of problem where I would I'll spend days on that type of thing, trying to learn like everything about how to parse that data. So it's good to take that project-based approach, because you are going to run into some roadblocks, right? And you got to get unblocked. But for this approach, though, because I don't anticipate using any of these projects for my portfolio. Except that first one I might, because it's so general, right? The oh, I don't have it up anymore. But the first one, it was very general, so you can apply that to a lot of things. The same techniques. So yeah, as in a variety of industries, I should say, to be more specific there. So yeah, I'm excited to work through that book. I'm probably going to go pretty quickly through it and not really focus on my solutions so much as just trying to get into the project building mode, right? And I'm not sure how long that's going to take, but yeah, we'll see. And kind of like I'm kind of leaving the door open to whenever there's the inspiration strikes me to solve a problem on my own to I don't know what's going on here. Oh, weird. Okay. R is not attached. Yeah. So whenever I find the inspiration to ask an analytical question that I want to solve and answer, I'm probably gonna leave that door open so that I can go through it and focus on building that project out for my portfolio. But for now, I'm just trying to get inspiration from reading David's book and working through his results-driven approach, which I'm looking and I'm like, this is just like general problem solving, basically, right? So I'm seeing a lot of parallels, synthesizing a lot of information as I go, and yeah, so we'll see. Hopefully at the end of this week I have a good idea of the projects that I want to work on, but we'll see. So getting back into the let's execute all cells above there. Practical statistics for data scientists, and reviewing some distributions here. The binomial distribution, which I know pretty well from my days of playing poker and analyzing poker decisions and stuff. Doing doing analysis with expected value and the like. Let's see. Yes, no binomial outcomes lie at the heart of statistics, since they are often culmination of a decision or other process: buy, don't buy, click, don't click, survive, die, and so on. Central to understanding the binomial distribution is the idea of a set of trials, each trial having two possible outcomes. So I kind of want to get this up as well. Binomial variable. Okay. We're gonna bring this one up now, because we are going to need this. Is this in Java? Did I move this over? I don't know where I got this definition from, but I think, yeah, I like it. Right, there's a fixed number of trials. Each trial is independent of the others. Each trial has only two possible outcomes. That's why it's binomial. And the probability of an outcome is the same between trials. So it doesn't change. I wonder how you would formulate a distribution based on that. The probability changes. Like, depending on how many trials. Maybe, I don't know. Metric. Let's get a new note going here, and I'm not gonna do this way. It's data science, and we're gonna do statistics from that. Statistics and mathematics as well. I mean, these are kind of, I don't know why I have these in both data science statistics and mathematics statistics. I could just put it in data science and the mathematics statistics, and that is the same thing, but I don't know. That's just the way I'm doing tags. Let's see. So, how do I want to do this? We're going to move this to job notes. And then, yeah, so we have binomial variables. So, I'm going to flesh that out a little bit better after this. Okay. As we go along here. So, set of trials, right? And so we need to define what a trial is, I think. Yeah. I think we just use that, right? So a trial is an event with a discrete outcome. Should flesh out what an event is, right? A coin flip is an example, right? So I could actually do this. There we go. Discrete outcomes are heads and tails for a coin flip, right? It's an example. Say that coin flip has heads and tails. As a discrete output, that's right. Okay. Flipping a coin 10 times in is a binomial experiment with 10 trials, so we need to understand what a binomial experiment is too. So each trial having two possible outcomes, such yes or no, binary outcomes that can need not have 50-50 probabilities, though any probabilities that some but one are possible. It is conventional in statistics to term the one outcome the success outcome. It is also common practice to assign one to the more rare outcome. Use of the term success. So I'm going to highlight this. That's weird. I never really heard that. Assigning one to the more rare outcome. I need an example of that. Use of the term success does not imply that the outcome is desirable or beneficial, but it does tend to indicate the outcome of interest. For example, loan defaults or fraudulent transactions are relatively uncommon events that we may be interested in predicting, so they are termed ones or successes. Tail side of the buffalo nickel. Get the definition of success. What's your definition of success? So trial, trial. Yeah, we could do like synonym. synonym. Synonym's going to be as opposed to 0, huh? Do outcomes, and we could do synonyms for this as well. The binomial trial. Fun. Okay, so so a Bernoulli trial. Right. Have any notes on Bernoulli? Nope, no, nothing on Bernoulli's. Let's go with binomial distribution. I think we have that. No. Oh. Well, duh. Yeah, we're right in that file. Success count. Say over X trials, so we'll just same one. What's going on there? Bernoulli distribution. Okay. Here we go. So the binomial distribution is the frequency distribution of the number of successes X in a given number of trials with a specified probability of success in each trial, right? So there's a family of binomial distributions, right, depending on the values of N and P. The binomial distribution would answer a question like, if the probability of a click converting to a sale is 0.02, what is the probability of observing 0 sales in 200 clicks? Or you could actually just answer that as 1 minus 2 to the 200, right? Or 0.98 to the 200. So it'd have to fail. So it'd be, yeah, 0.98 to the 200. So dbinom is the R function, but we're not going to use R. So it would return 0.0729. Right, so often we are interested in determining the probability of X or fewer successes in trials. In this case, we use the p-binom. So, okay, the SciPy stats module. I think I have that already loaded. I'm not sure though. Maybe not. There we go. So what's the probability mass function? It's a point estimate, isn't it? Or no? I don't know why it's returning NP floats. How do I get it to return just floats? Seems like a... let me see. Like, I don't want to... There's got to be some way to change the... Yeah. Change the precision. Rather than casting it as a float every single time. I mean, you do want to use that, and like this is just for reporting though, so like, what happens if you print it? Oh, there we go. Okay, I'll just do that. Okay, that must be the string representation of it. Is that? Yeah. Okay, just have to do that every time then. Rather than cast it as flows, same difference though. Same number of characters. Let's see here. So probability of 2 successes in Oh, the CDF, so up to 2, right? Or up to including, I think. These are not good. They're not good suggestions here. I'm going to read the documentation here. Put that up here. Where's Binomial? Oh, because, yeah, discrete. Get my language correct here. Probability mass function. Probability mass function. That's like synonymous with density, right? Yeah, so PDF and then EMF are the same thing, I think. Okay. Get more information about that? That's it? There's no more. That's the extent of the documentation. Okay. Great. Great job, guys. Yeah. Okay. I'm pretty sure this is inclusive. I could test that. I could test that. So if I did, let's do. Probability. We'll start at 0 and then we'll just add up from there. For to exclusively yeah, so it is inclusive. It's inclusive. So if we do that, then it's that. Yeah, that's correct. Okay. The mean of a distribution n times p. So think of this as the expected number of successes. So I could put this in stats. We could say like the mean. The mean being 1 times P. Terms, definitions, stuff like that. Okay. For that as well, which is not going to prove any of this. Oh, it's fun to prove those things. Pretty easy proofs. Alright, calculating binomial probabilities with large sample sizes is computationally demanding, yeah, because you're using whatchamacallit. Well, I'm not sure. So most statistical procedures use the normal distribution with mean and variance as an approximation. Interesting. Yeah. Yeah, so when the probability is close to 0.5, it's virtually indistinguishable from a normal distribution. But yeah, you need a large enough number of trials. And that's not that... I don't think you need that many, actually. I think there was something in the code about that. All right, let's go back to key ideas here. Let's see. Key ideas, a binomial outcome are important to model. Fundamental decisions. Using the law of the excluded middle there. Not too close to 0 or 1. Right. Because then you need even more, even more trials. Yeah. Even more trials to get it to approximate. Don't know what that has a name to it. The quincux. What's a quincux? I don't see it there. I think there's a broken link or something there. I don't. Is this a? I don't see any reference to a device or simulation device. I guess he doesn't want to call it a Galton board. Because he's definitely problematic. Francis Galton has a problematic history there. We don't, maybe not put his name on things that don't need to be put on there. Yeah. I think this is what they're talking about. It's going to approximate normal. Staple. All right, and then we're going to look at the chi-square distribution. Let's zoom in a little bit here. Oops. $170, I think, was where we were. Right, not much going on here with this one. Chi-square distribution. Important idea in statistics is departure from expectation, especially with respect to category counts. Expectation is defined loosely as nothing unusual or of note in the data and no correlation between variables or predictable patterns. It's also termed the null hypothesis or null model. So you might want to test whether one variable is independent of another. You have counts of a number in each of the cells of the data table. The statistic that measures the extent to which results depart from the null expectation of independence is the chi-square statistic. It's the difference between the observed and expected values divided by the square root of the expected value squared, then summed across all categories. Yeah. Yeah. Didn't want to put the equation there or the formulation there in mathematical terms there. Mathematical notation. This process standardizes the statistics so it can be compared to a reference distribution. A more general way of putting this is to note that the chi-square statistic is a measure of the extent to which a set of observed values fits a specified distribution, a goodness of fit test. Useful for determining whether multiple treatments differ from one another. And the chi-square distribution is the distribution of this statistic under repeated resample draws. So there should be some definitions to pull out of this, but we didn't really. Yeah. It's a bit lacking as a section goes. A high chi-square indicates that they differ markedly from what is expected. There are a variety of chi-square distributions associated with different degrees of freedom. Number of observations, see degrees of freedom. All right, so we're just going to go here too. Yeah. See if there's a chi-square thing here. Yeah, so it's usually chi-square as a test, right? Perform Pearson's chi-square test. So let's go take a look at that one. Surprised there's no example given in this one. This is kind of very lacking as far as sections go. Yeah, we'll come back to the F distribution later tomorrow. Yeah, okay. P-value of a test, the value is a float. What is DDOF again? It's the degrees of freedom, but it's dependent degrees? No. That doesn't make sense. The distributed degrees of freedom? I don't know. It's DDOF. Delta degrees of freedom. What does that mean? Denominator degree? Delta degrees. It's not degrees. Oh, right, because it is like, if you have 1 degree of freedom, then you don't really anything, then... Yeah, it's N... Shoot, I don't remember. The default's 0. Usually I thought your degrees of freedom were like the number of categories, or, yeah. A number of categories. The number in comparisons, I think. Have I heard about All of Stats by Larry Wasserman? No, I haven't. Let's see. Oh, somebody has a self-study guide here. Oh, that looks good. Might be in hypothesis testing. Let's see. There we go. Interesting. Telmo Korea. Hmm. Oh, here we go. Here's an example using the chi-squared. That's interesting. Thanks for sharing that. Where's the star thing? There we go. Add that to my notes today. Yeah, I see that he's using Python. Interesting. Let's get the book here. Oh, this might be a good resource. Although I might need some primers on some probability again, just to fill in some gaps. I'm probably not going to touch much linear algebra in this run. That's for another block of of time, but I'm just focused on getting some portfolio projects and trying to get a junior job. But thank you for sharing that resource. That looks really promising for future study. Oh, he does expand later on in the book, I guess, with doing hypothesis testing. Okay. I'm hoping to get to the hypothesis testing part of this stuff. That's gonna be chapter 3. Yeah, I should be able to get to that. Right, I have that scheduled for, I think, starting next week. I'm gonna do chapter 3. So I'm just gonna pick back up on the F distribution when I get back to that. Okay. So I'm gonna jump back into David's book here. And we're gonna be doing a new project as well. Just consolidate my notes here. Just use that down for the day. To get that settled. All right. Chapter 3. So chapter 3 covers data modeling. Modeling data as a fundamental analytical activity, how to define business entities from raw data, how to structure a data model to best suit the analytical question. So as an analyst, you will find yourself applying the same logic to raw data over and over again. For example, every time you calculate revenue, you might need to remember to remove internal money transfers between departments, or when you look at customer spending, you might need to exclude a certain customer because they operate differently. Whenever these business rules need to be applied constantly to ensure data is accurate, it's a good opportunity to build a data model. A data model is its data set created from raw data, has been cleaned with specific business rules built into it. Creating reusable data models will save you time and maintenance headaches in the future. Data modeling also forces you to think deeply about your and your stakeholders' question, which leads to a more favorable, more valuable answer, right? Okay, so the business use case here is customer deduplication. Once, when working in industry, he spent months on a customer deduplication project. Wanted to track the number of customers over time. Customers were spread across multiple databases. Deduplicating was not a trivial task, especially because in some databases, customers appeared as company names, such as Southwest Motors, and in others, they were recorded as individuals, such as John Smith, with no information about the company they worked for. In the end, our solution involved text similarity algorithms. Yeah. To find instances where Southwest Motors from one database existed as Southwest Motors Limited in another. We also use graph theory to link customers together across our company network. These are advanced algorithms for the seemingly simple task of counting customers. Entity resolution problems are everywhere, which is why this chapter explores the topic and lets you practice on a real problem. In this chapter, review the fundamentals and importance of data modeling and practice converting raw data into a reusable data model using a real-world project. Okay, so data modeling is a foundational step in the analytical workflow. It's the process of taking raw data, mapping it to business-specific entities, and creating new data models. I'm going to actually keep a note there. So I do have some stuff on data modeling. I need to tie these together. Oh gosh. Let me see if I can remember how to do that. Data view query for this. Actually, let's get a list of them. Can be from anywhere. But I need to find where the title. So it's I forget which function they're using. Contains word. That's what we're looking for. Can we ignore case? Let's try that first. Okay. Let's pop up. I wish I didn't do that. Oops. Yeah, so I'm gonna have a lot from this blogger. Oh, okay, that's my note. For some reason I saved the wiki from there. Don't know why. Is this repeated? It is. Hate how they did this. This is the updated one, right? Yeah. Probably gonna take a break for lunch. It's gonna be a long one because I have to do something at, let's see, what time is it? Maybe I'll wait. Yeah, maybe I'll wait for another half hour. Yeah, so I think I'm gonna, let me see, because then that's 45 minutes from when. It helps come back at 2 o'clock. So, yeah. 12:30. Yeah, so that'll be an hour and a half. That's what I'll do. So I'll give this another 25 minutes. And I'm gonna take a break. But I just need to work through my notes here and gather my notes on data modeling. And clean up these Readwise articles here. Yeah, so what I'm gonna do. Analytics. Do I have a thing on data modeling? Oh, I do. Engineering with that. Okay, so that's kind of in the same vein, though. Hmm. Complete this as much as possible, but I'm gonna get a late start to that, so it's probably gonna bleed over till tomorrow to do this chapter of this book here. I did want to just hard code these links into here. What's the best way to do this? I mean, I could just copy and paste. Probably the best way to go. No, really? Now I need to find the query. Where's the query? That's what I want. I don't want tasks though, it's not a query. I'm not interested. I'm looking and searching. Not on tasks. I really don't like the approach that they trying to make this the everything app, I guess. These are all just oh, that's tasks user guide. I don't want tasks. I want search. Query in search. um, Here we go. Embed search. So I want to find with a search results. Embed or search. Embed. What does that mean? Embed. Embed or search. Find text and file names. So that's what we're looking for. There we go. Oh, sure. Yeah. And can I... How do you embed? I don't know what that's doing. Yeah, I don't know what's going on there, I think. But, like, I can't copy the results. How do I... Yeah, that sucks. Okay. um... Yeah, I think I'm just going to do the other way. Really? Doesn't go that far back? Okay. Can I copy the table if I do it as a table? No. Oh, you suck. So bad. I can just open this up next to it. uh... There we go. There we go. There, okay. My related notes then. I can just close all these other ones down. So I'm going to flesh out this note a little bit more today. I'm just going to use this as my note. Okay. Points of data modeling, foundational step in the workflow. So I wanted to have a definition here. Let me actually go to over here as well. Can I put that in there? I can. Okay. This was from Reader. This is data modeling in the data engineering sense, with linking tables and doing that stuff. I'm not sure if he's going to do a similar thing. Let's look up a definition here. Let's just see data modeling. It's the process of taking raw data, mapping it to business specific entities, creating new data models. Okay, interesting definition there. Analysis. Well, we can think of it converting data into raw state to a more useful form, which we can call information. Well, I mean, true. Data analysis is then the process of converting this information into insight. The intermediate step is required in its raw form. Data is often not ready for analysis. Data modeling fits into both the abstract and concrete versions of a data science workflow. Data modeling and analysis is mapped to the data science process. There. Okay. Data models should encode any business logic required to transform the raw data to be suitable for analysis. If you always need to remember to filter out certain rows from your raw data, you should have an intermediate data model where that filter has already been applied. What does a lapsed customer mean for your business? Is it somebody who hasn't purchased anything for a certain time? Perhaps someone who hasn't even logged into the platform for a while. Whatever the definition, it should be encoded in the data model. That's going with like the data dictionary type of idea there too, right? I mean, you do put like KPIs and stuff in a data dictionary to define your metrics and stuff, and like how you actually calculate those things as well. Creating data models increases transparency because there is a single place to look for how a customer, vehicle, or a purchase event is defined. All other analyses should be done using these intermediate models, not the raw data. Another benefit is that this kind of cleaner data model could be exposed to data-savvy stakeholders to work directly, thus enabling self-service, but business intelligence tools such as Tableau and Power BI allow power users to create their own reports. If that is done using centralized data models, analytical mistakes are less likely. As analysts should be looking out for opportunities to standardize business logic by encoding it in data models. These don't have to be technically complex. Since they simply be additional tables in our database, let's look at some tasks involved in data modeling, which we'll then practice in the project. Data modeling usually involves some combination of repetitive data cleaning tasks, such as fixing. Let's try to see like. Who's his name again? Asboth? Yeah, that's his name. Okay. Let's say. Right, so I'm gonna go for lunch and be back in an hour and a half. So all the tasks you do not want to perform every time, you need to do some analysis, right? So it should be done once, and the output should be captured in an appropriate data model. Okay. put a footnote there? Yeah, that's it, right? That sucks. Why does it not work inside of there? Oh. So I was doing it wrong. That's why. Okay, so this is the Well-Grounded Data Analyst. There we go. And 1-1. Why is it repeated? I don't know why it's repeated. If I delete it, it's only referring to the once. I don't know. All right, going on break, on lunch. I will be back in an hour and a half. So, see you later. See you soon. Okay, so I'm going to get back to the Well-Grounded Data Analyst, and we're going to work on this data modeling project. And let's see what we can do here. What can we do? Let's get some music going on here. What I'd like to do is to get the music, yeah, something going on with the... I gotta figure that out. That's for another day. Yeah. I can ask Josh if he has the threes. Maybe there's a way to do it off of title. Ooh. Oh. How do you use this? Oh my god, that's fascinating. Okay, wait a minute. I'm gonna try something here. Talk amongst yourselves. I'm gonna try something. Um, right. And so, oh, I could do it from the other thing. You know what? That would probably be pretty sensible there too. I think I installed UV in there, but I think it's fine here. Okay, so we have that one. So can I? That's not found. But how do you source the band? Oh, there is one there. Oh, sweet. Okay. UV lock. Okay. Yeah. So what I want to do. Okay. How do you high QT5? Oh, maybe I can't do that. You know what I'm gonna do? I'm gonna SSH into my other thing, and then what I'm gonna do is it'll download it to a different thing, I think. That's what I'll do. Yeah. Comments here. Here we go. We're gonna go to templates and PD. I'm gonna do this. Do I want this in documents? I don't know where I want to do this. Is there? So where do I want to do this? That's weird. Oh. Okay. Oh. Okay. This seems to be working. added these things correctly. Boom, bum, bum, bum. Yeah. Okay, let's try this again. Client side. Ah, that's the VM. Interesting. Oh, okay. I gotta figure out how that is. Fonts. All right. Okay. Ah, okay. What's the V anyway? Oh, there's something there. There's nothing there. Maybe it sets it when it downloads it. Okay, it's only 2 meg. Why is it taking so long? What the heck? Wow, what's going on there? Very slow internet. Upload speed's fast, but the download is really terrible. Hmm. Hmm. Right. Okay. Maybe that's just the problem. Okay. How do we restart? I think it's gonna be because you have to. I think I have to do something here. How do you change the? Mm. 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 So if I edit it on there, is it going to be the same thing? That's the question. Wait a minute. Hope that works. That might not work. There we go. It's not generated. Okay, so that still doesn't work. Yeah, it's still not working. I don't know. I think try to do it by we don't need to have the GUI. I guess we can do it by doing something else. Open this up. We want to see the title thing here. Okay. All right. That's not working, but it's okay. All right, that's gonna be the download thing, I think. There we go. I got that. Okay. Okay, so let's go. That's so fun. Okay, so we want to download by URL. So we need the list of all those things. How do we get a list? Hmm. on that stuff. Okay, so that's going. I'm just gonna clear my desktop a little bit to make it a little easier to work with here. And did I start this one? Didn't mean to do that. That's okay. Bear with me for a moment. So. Okay. So we're on agreeing on terminology in Chapter 3. So as a junior analyst, you might end up in an industry you're unfamiliar with. It's important to ask questions to clarify the terminology, right? Because even everyday terms like customer might have ambiguous meanings. Does a customer mean a single person or an organization? What if your business deals with both? Part of the data modeling process is defining these terms so they can be encoded in a data table. When it comes to definitions, you can't work in a vacuum. Decisions about what concepts mean concretely need to be made in collaboration with your stakeholders. Right. Okay, so handling duplication. Data you work with will inevitably contain some duplication, which might be in the form of duplicated rows of data or duplicate records across multiple systems. If you worked in the automotive industry, you spend a non-trivial amount of time figuring out whether John Smith Motors in one database is the same customer as JS Motors in another. Time invested in reconciling this at the data modeling stage is time well spent. Yeah. So, depends on how much time you need to spend on it. Another important data modeling task is deciding the structure of your data, such as whether the data should be stored in a wide or a long format. And so wide versus long data, we should make a note of this somewhere. Oh. Narrow versus wide transformations in Spark. Narrow is no shuffling, wide is shuffling. Oh, that's kind of a weird thing there. Yeah, so I think wide and long data. Let's go. Yeah, so I think there's just one. That tag. Okay, so we want like I thought I had like a note on this written down somewhere. Or maybe I don't. We talked about this with what was it? The pivot tables. Where if like you have wide data is like one example is that like when you have wide data, you have like every row is a single, like with time series, it's like a single day or it's a single discrete unit. Um, and you could have yeah, where like the columns could be like categorical, where it's like whether or not a certain value exists for a certain place, right? So you could have it as, well, you could have like could have something, let me do something like an example here. So if Y data could be like date in one thing, and that could be like the time there. Could be like a whatever. You could have like state populations, right? So you could have like, let's go with Alabama, Alaska, or actually Alaska comes before Alabama, right? And you could have wait, A B A C A D A E A F A G A H A L H A I A J A K A L A M N E O A P A Q A R. AR is Arkansas, I think, right? AS AT A whatever, and just like have dot dot dot, right? And go all the way up to Washington and Wyoming. I think those are the last ones, but there's no others, right? After that. And you could have like a date here. So let's say like 2024 01 2, and then like there's like numbers in these things. And like something like that, right? We have some observations, and then you just have like dates there. A long data then would convert that to something like this, where it would be state as a single category, and you'd have it broken up into two different columns. So the next column would be like something, let's just say like let's say like incident count or something like that. Something along those lines. It would be like 526 there, and then let's see. Okay. And then I think you can do vertical dots there. That's okay. We could do it as this, actually. Yeah. With LaTeX. Let's see, we could also be also Washington, and we have one. See what happened. There we go. So let's like that's what wide versus long data is, right? Is that you'd have something like that, right? Where this gets turned into that, basically. And you can transform it in the other way as well. You can go from wide to long and go to long to wide. basically you're taking like one column, or like you're taking a list of columns and you're converting that list of columns into two columns. One which has the column name and the other which has the value, right? That's something I should like do that. So transforming wide to long. And so what that means, take a list of columns, right? Into two columns. One with the value, one with the column names, and then the other is with the value. In the wide table, right? In the list, I'll just say, right? So you take a list of columns, right? You turn them into two columns where column names and the value are the two columns, right? Basically, that's kind of the example that I try to think of, right? So let's see how David explains this. I think that's going to be probably a similar example here. So already I see his example here is it's not exactly fully wide. This is more long to me. I think that's wrong. I think it's wrong, isn't it? Oh, because yeah, it's wide in some sense. Wide in respect to these two columns, the homocos and the wagos. That's what he's saying. So right. So otherwise, like this does look like it could be almost long. It's not exactly in the long format, right? It's almost there. It's almost there. In many cases, data will consist of one row per entity, such as a customer. So each row represents a customer. Each column represents a property or attribute of that customer, such as their name, age, department, and so forth. This is called a wide format because of the number. As the number of measurements grows, the data gains additional columns. Okay. I think, oh boy, I wish I had like taken better notes on that. Actually, I think, let me grab that. Taking a look at Kieran Healy's data visualization book has notes about this, and I think he has a good definition here. I would like to use his definition rather than this kind of. I don't want to like poo-poo David's idea here, but I really think it's a little too loosey-goosey, and to be more precise, I think Kieran Healy has a better definition for it here in this book, which I don't know where he got it from, but let's see, probably see wide data. I could be mistaken as well. So table, wide, table. I'm not seeing it here. Data wide format, long format in 56. Page 56. Let's see. Maybe I took a note on this. I wouldn't be surprised. Oh, I skipped it. Interesting. Well, I could be mistaken here. Maybe he does have a very similar definition here, because it's with tidy data. Wide format and long format. So he says in a long format table, every variable is a column and every observation is a row. And compare that with this. One row represents a single measurement of an entity. Every variable is a column. Every observation is a row. I mean, in wide table format, some variables are spread out across columns. Actually, I take that back. I think this is a little bit more loosey-goosey. I thought that there's an actual definition in this. I take that back. So, if Kieran's looking for something to update in the second edition, maybe be a little more precise with the definition of wide versus tidy. So let's see. In wide data, one observation each column represents a variable or an attribute. Actually, didn't we do this? Didn't we? Environment variables. I really wish I knew where I put that. What's this on? Oh, that's a Linux question there. Interesting. What was the thing? I know I'm gonna have trouble trying to remember what it was located in. Data is going to be 2. I think it's the data types. No. Not data storage types. I don't remember. Fields, observations. So I'm gonna see if we have anything on observation. Just trying to tie those ideas together. Oof. Okay, let me go back to wide versus tidy here. So long data, according to, let's go, yeah, so I'm going to say I still have that in there. No. Um, the Well-Grounded Data Analyst is from there. And then we also have here in Healy's definition in there as well, which is going to be, I should make a note on this. What I'm going to do is practical introduction. So we'll create that note. So Kieran Healy's here. Tidy data. Long format. Every variable is a column. So with wide, each row represents one observation. The data gains additional. I don't know if that's true. Each row represents a customer. It's not an observation. Each row is not an observation. One entity is probably more like what he's going for. So rather, it's closer to the language, generalizing from the specific customer to like an entity. There's going to be so many in here. 74. That's not that many, though. But there might have been more. So I wish I could, like, can I, like, collapse all of them? Collapse results. That's what I want. Yeah. Tidy data. That's what I'm looking for. Okay. Let's go for that one. I knew I had something. Maybe I'm going to combine those two notes is what I want to do. Oh, wait a minute. Right. The tidy data is the standard way of mapping the meaning of a data set. Yeah, right. So this is how to create pivot tables with pandas. That's from... So tidy data is organized as follows. Each row should contain a single record or observation. Each column. Oh, okay. You know what? Now I'm going to actually... Because this isn't exactly what we're looking for. Long data. Tidy data is a standard way of mapping the meaning of a data set to its structure. Yeah, each variable forms a column. Each observation forms a row. Each type of observational unit forms a table. See, that sounds like long format to me. Right? Each variable forms a column. Each observation forms a row. That's long format. Hmm. So he's kind of saying that, I think. Hmm. I think what I'm remembering from this book is that I spent a lot of time on this page, like thinking about it. And so, like, I think I clarified in my brain the language in this section. But yeah, okay, so he only really explicitly lays out the wide long data. Doesn't concisely lay out the idea of wide data. It's more done with examples, which I just did too. So let's see. Okay, so long data, according to David here, we have so I think this is like, I don't know, this language is a little weird to me. I don't know if this is like, it's clearly wide, but I don't think his explanation is like, it's a little muddy to me. A single measurement of an entity. See, to me, that's wide. To me, that's wide data. An entity such as a customer will require multiple rows. I can see. I feel like this could be better fleshed out here. I understand where he's going with this. So a customer could be like, it could be observations of customer behavior. So a customer could go across multiple rows. So it could be like purchases. And then so each row would be a purchase. Yeah, I'm not, I don't know. I'm spending a lot of time on this. When a new measurement about the entities is added, the data gains additional rows. Right. This has always been like the kind of sticking point for me with, that's why like it's hard to define wide data versus long data in like definitive terms, in like precise, like this is the exact definition, without like ruling something out. Without being like, well, like you have this table, it's, you know, clearly like this table 3.1 is like almost in wide format. If you take a look, like it's almost in long format. The only thing it's missing is this home goals and away goals. Like everything else, you have home team, away team, you have the round, you have the competition, you have the date, right? That's almost in long form. If I were just like looking at the first 5 rows, if you like, it's so close to being in long form that like if you eliminated home goals and away goals, it would be in long form, in long format. Yeah. Long data, one row represents a single measurement of an entity, and yeah, I think I mean, this is kind of like his thing. So it means an entity. This is basically his exact definition. One row represents a single measurement of an entity. It's the long data. I don't know if it's precise enough, or yeah, seems like accurate, but I don't know if it goes out enough to be precise enough for a definition. Long data every column. So this is what I'm kind of talking about here. So wide data that I want to do. Oh, I could do it like that, right? Yeah. I shouldn't put that under there because that's kind of making it seem like that's his example, but it's not. So I'm gonna like use my own examples here. So terms, you got that, and then you have wide and long. Transforming wide to long. I like my explanation here. Take a list of columns, turn them into 2 columns. So this like subset of columns. Take a list or a subset of columns and turn them into 2 columns. One with column names One from column names and the other from the value, right? Okay. Spent way too much time on that, but just want to get the idea clear in my mind. So it's wide data because each row represents an entity. In this case, a match. Each one represents a match. Right. Each row represents one entity. That's kind of what is getting at there. Each column represents a variable of that entity. So this data set would allow easy analysis of questions such as which country has won the most games at a World Cup. Oh, what happened there? We reconnected, we disconnected. Weird. All right. Oh, actually, yeah, home team and away team. Oh, because the team could be put into that, right? Ah, I didn't see that for some reason. Yeah, so it's almost in long format because of that. Okay. Oh my gosh. Okay. Yeah, I was wrong there. Yeah, it's wide because of the home team and the home goals and the away team and away goals, right? Okay. What if someone asked which country participated in the most World Cup games? We could consider creating a long format version of the data that would look more like table 3.2. Ooh. One row per match participant. And this is now long data because rows don't represent unique entities. The table encodes the same information, but each match is duplicated on purpose. From this table, it is easier to focus only on the team column. Yeah, I'm feeling a bit foggy right now, so I think I'm going to take a break and yeah, let me take a look at this. The table encodes the same information, but each match is duplicated on purpose. From this table, it's easier to focus only on the team column to find the team with the most World Cup matches. The downside of this format is that we cannot simply count the number of rows to find statistics such as the number of games played at a World Cup because we would be double counting. Neither a wide nor a long format is better than the other, but the choice between them depends on the answer you're trying to answer, question you're trying to answer using the data. Assessing what format is best suited for your analytical question is the essence of data modeling. Okay, right. Never really thought about wide versus tight, wide versus long data as being a part of data modeling. It's a little bit of a different notion from what data engineering is, I think. So it's good to know this that the language is maybe slightly different between data engineers versus data analysts, as far as the data modeling is concerned. And yeah, I want to come back. We're gonna finish out the identifying the right level of granularity, and then I'm gonna jump into the project. So I'm gonna try to go for a few more hours here, maybe like another 2 hours, maybe. Not sure. Maybe another hour. Depends on how we feel. But yeah, I'm gonna take a quick break. so I'm just gonna, yeah. We'll just pick it back up tomorrow. So, yeah, that's fine. Have a great day. I'll see you tomorrow if you join me. Bye-bye now.